Hello, welcome back. Today, we'll delve into a fascinating case study on holistic inventory optimization at Sophus. First, let's introduce the company at the heart of our case study. Biolex is a global frontrunner in the development and production of innovative medical treatments. With a focus on immunology and infectious diseases, Biolex prides itself on its varied and evolving range of new drugs and biological products. However, as a global corporation, Biolex faces several inventory management challenges. As an international corporation, Biolex faces distinct challenges in managing its inventory. Central to these challenges is a diverse range of 176 unique products, each characterized by its specific type and value. Furthermore, Biolex grapples with unpredictable product demand, a consequence of the erratic nature of health crises and regulatory shifts. Lastly, the company currently maintains high inventory levels, placing significant pressure on reducing inventory holdings. Let's now take a closer look at Biolex's existing supply chain and the challenges it faces. Biolex's supply chain begins with importing active pharmaceutical ingredients, API, and finished products, FP, from overseas suppliers. These imports pass through ports, customs, and quality checks before reaching Biolex's packing facilities. After production and testing, the medicines are sent to the Central Distribution Center, CDC, before shipping to various regional distribution centers, RDCs, and customers. The multi-echelon nature of Biolex's supply chain introduces several complexities in inventory management, considering various production and shipping times, customs clearance, and order frequencies and quantities. Understanding Biolex's product diversity is crucial in managing its inventory effectively. Biolex categorizes its 176 products into 4 distinct types, each with unique characteristics that influence inventory management strategies. Products such as bulk repack, FP import, and raw API, primarily sourced overseas, generally face longer lead times. For example, these products from overseas have longer lead time, so we can specify different MOQ and frequency for each type of product. Next, let's examine the key inputs for building an inventory optimization model on Sophus. In creating an effective inventory optimization model for Biolex on Sophus, several critical inputs are needed. This includes the value in the product table for inventory holding cost calculations, forecast mean and error for demand uncertainty, and lead times of production, transportation, and sourcing in different policy tables. Additionally, defining service types and service levels is essential in setting goals of safety stock. Now, let's explore the baseline results to understand Biolex's current situation and identify inventory reduction potentials. Using the current business variables, we established a baseline to understand the breakdown of different inventory types of Biolex. We identified significant costs in cycle stock and in-transit inventory, with safety stock also posing a challenge. By analyzing this baseline, we aim to uncover opportunities to trim down inventory costs. Let's see how this plays out in Sophus. Next, we'll summarize the business levers impacting inventory by type. Our analysis revealed that 31% of inventory costs are tied up in in-transit stock, influenced by factors like production and shipping times, as well as customs clearance. Cycle stock is the second largest inventory type at 30%, impacted by MOQ, frequency, and testing time. Safety stock and work in progress, WIP stock, are also affected by various levers, including lead time, forecast error, and on-time in full OTIF targets. Understanding the different inventory types and the factors affecting them helps us design the scenarios to test potentials to reduce overall inventory. In summary, our approach involved testing business levers for inventory reduction via Sophus. In the baseline analysis above, we identified key issues in inventory stem from factors like low forecast accuracy, high MOQ, and lengthy lead times. Our solution, create test scenarios in Sophus X to test alternative inputs. Utilizing Sophus's dashboard, we've created a visualization to aid in understanding and comparing scenario outputs. Observe how safety stock, in-transit inventory, and cycle stock form the bulk of the inventory costs. If BioLex can find more historical data of the demand, like expanding from 1 year to 3 years data, the forecast error would drop. In another word, the demand forecast accuracy will improve. By enhancing demand forecast accuracy, we can potentially reduce safety stock costs. We've modeled a scenario that halves the forecast error. We can use scenario items to update the input. For instance, let's say BioLex finds a way to improve forecast accuracy and reduce forecast error by 50%. We can then create a scenario item to multiply the forecast error column by 0.5, and we can create multiple scenario items for one scenario by simply drag and drop to set up a scenario. Okay, let's run this forecast error reduced by 50% scenario and observe the results. Back at the dashboard, you'll notice a significant drop in safety stock costs exceeding 50%, with other inventory costs remaining stable. Moving on, we target cycle stock reduction. Key factors here are minimum order quantity, MOQ, and ordering frequency. By lowering MOQ and increasing frequency, as seen in our scenario, the cycle stock visibly diminishes, confirming our strategy's efficiency. Addressing the high in-transit inventory cost, we look at scenarios improving lead times, including production and transport times. Reducing these by 2 weeks shows a marked drop in both in-transit inventory and safety stock costs. Finally, considering that medicines must undergo testing, accelerating test times and increasing frequency can significantly benefit cycle stock. Our scenario reflects this potential improvement. Now, let's contemplate the cumulative impact of all these improvements on BioLex's inventory. Let's now examine the potential savings from integrating all these levers. The dashboard illustrates that Scenario 2, which incorporates all these levers, offers a potential 33% savings in a best-case scenario. Finally, we'll discuss how different service levels impact inventory costs. Driven by a vision to revolutionize patient care, the board of BioLex called for an ambitious evaluation of service levels across all product lines. The goal was clear: elevate BioLex's OTIF service levels to match its reputation in pharmaceutical innovation. To thoroughly grasp the trade-off between inventory and service, we designed 6 scenarios. These scenarios test service level targets ranging from 97.5% to 99.8%. The intent is to reveal how inventory, specifically safety stock, responds to different levels of on-time in-full OTIF targets. With this context in mind, let's now explore the results and their implications on inventory management. Our findings are quite revealing. The results demonstrate an exponential increase in safety stock as the OTIF target nears 100%. This highlights a critical trade-off in inventory management. The quest for higher service levels inevitably leads to increased safety stock, impacting overall inventory costs. Thanks to this analysis, the management team was able to make a well-informed decision regarding the trade-off between inventory and service. Thank you for your time. I hope this case study has given you a glimpse into the extensive capabilities of Sophus X in effectively modeling the complexities involved in inventory management.